This is video 2 showing pumps and compressors with the specific example in preparation of a toluene feed flow rate of 100 pound moles per hour at 70 degrees Fahrenheit, 20 psia, and we want to heat that up to 450 F at 75 psia. So our simulation from before is here. Now we can add in utilities to make use of these work and heat streams. But in order to do that, we have to click on Utilities in the left-hand hierarchy. We want to specify a new one. Now we can specify a completely new utility. However, because we want to specify electricity for pumps and compressors, and we want to specify the use of high-pressure steam for the use in our heat exchangers, we can actually copy from an existing database. So at the very bottom we have electricity. So we can just copy that one, and that one shows 7.75 cents per kilowatt hour. I'm going to say 10 cents per kilowatt hour. So now we can specify a new one. We have our electricity, and now we want high pressure steam. Now it's important to note that if you continue down in the list, there is high pressure steam generation. This is not what we want. This is if we were to have an actual boiler producing that steam for us. We just want it as an on-demand utility, so we can specify just the high pressure steam. And note here that the inlet temperature is 250 degrees Celsius and the outlet temperature is 249 degrees Celsius. This will allow a 1 degree drop and manage the flow rate as a result, specifying the inlet and outlet temperatures for the steam. Make this a bit, alright, so let's see. We can specify the energy price or the purchase price. Now I'm going to specify the purchase price per 1,000 pounds as $8. So there we go. And our minimum approach temperature, we can change this if necessary. I'm going to go back to utilities and change the name of this one. So now we have our electricity and our steam, but now we need to go back to the blocks and specify which utility it's going to use. So block B1 is our duplicator. We don't need to worry about that. So the utility tab under the compressor, we can specify we're going to use electricity to run that, as well as pump 2 and pump 3. Each heat exchanger will use steam as the utility. So now that we have all of those, we can now run it again, and our results are now available. So if we click on our results summary drop-down menu, we can see our streams. Now here we have the heat, just like we did before, for all of our heat exchangers. We have the work, that did not change, and our materials, just making sure that our each process temperature and pressure at 450 and 75 psi. So we're good. Now our operating cost in our results summary, we can see our entire operating costs and our utility cost summary. So here we can check the duties, we can check costing rates, everything that we want to for our steam and electricity utilities. Now we can also turn on this capital cost estimation. We can see that for this flow sheet, it gives us capital cost estimation for our equipment, so all the pumps and all the heat exchangers. So for the 3 processes, our total capital is $2.6 million, and our utilities for all 3 processes come in at just over $800,000 per year. So we can take a look at our individual heat exchangers, look at our operating costs. So in order to run steam through this, it will cost just over $26 per hour. Heat exchanger 2 will cost a little over $30 per hour, and heat exchanger 3-2, which are vaporizer, about $13.50 per hour. So this is how we can add in our utilities to give a more kind of broad perspective of our process, or compare sub-processes to one another. So with this duplicator function, we're able to look at, again, process 1, 2, and 3 of this problem. And we get the approximate answers that they do from this textbook in terms of temperature and pressure, as well as flow rates. So clearly process 2 or 3 is preferred due to the extremely high cost of the compressor and the energy demand of this heater.